See, this is the diagram. Like a job tracker is there, task tracker is there. This is HFS, name node, 3 date nodes are available. And I'm submit a query immediately as a developer. I'm submitting query. Immediately job tracker respond, calling submit method step 1. Same 10 steps is the previous diagram. Just I'm explaining it to 5 steps. Just for your understanding. Step 2, job tracker assign one ID to the particular job. Then track the metadata from the name node. Check the output path, input path. The path is available or not. The schema is clear or not. Job tracker check those path. Then step 3, job tracker again adding jars and some supporting files to that particular job. If any jar files is required to add to execute the jobs. For example, pick yesterday we are adding some our own UDFs. Like that, any jar files is required to add, adding those jar files. Any supporting files is required to add, supporting those jar, adding those supporting files. After that, job tracker track the metadata information, nodes information. Step 4, which nodes are healthy, which nodes are unhealthy. See, for example, first storage time, we are storing our data into multiple date nodes. At the same time, the replication also happened multiple date nodes. Block 1 is there, one date node. Same block is there, another date nodes also. For example, you have 5 blocks is required. B1, B2, B3, B4, B5. And B1 block available 3 locations. B2, B3, B4, B5. Each and every block is replicating into 3 locations. Storage completed. Now I want to process the data. As a developer, I'm submitting the query. Immediately, job tracker respond. Here, job tracker means HFS client. Respond, assigning one ID to the particular job. Same story is going on again. Like calling submit method, adding IDs, track the metadata. What metadata? Track the metadata means, yes, this job tracker request into name node, give me metadata. What metadata? I want to execute so-and-so files. Where is stored? So immediately, name node transfer that metadata to job tracker. After that, again, job tracker track the adding any supporting jar files, any information. Job tracker adding all those supporting jar files. After that, step 4, find the node information. Nodes information means, for example, let's see friends, my data available 5 blocks, B1, B2, B5. But B1 available 3 locations, B2 available 3 locations. B3, B4, B5 also available 3 locations. But I don't want 3 copies. I want only 1 copy. I means job tracker want only 1 copy only to process the data. How to find out the job tracker that information? Based upon these date nodes health condition. So those only job tracker doing here. Track the nodes information. Find out the date nodes. Which date nodes are helpful. Step 4. After that, then finally job tracker sending the jobs to so-and-so task trackers, deciding task trackers, and those task trackers receive the jobs, submit the jobs into so-and-so date nodes. Once submit completed, immediately map reduce work started. What map reduce work started? For example, I have some data is there. I want to find out each and every word how many times repeating. Simple word count problem. I have deer, beer, river, car, river, deer, car, beer. This is the data is available. This data I want to count how many times each and every word is repeating. This is my requirement. I am writing pig code only, or else I am writing Hive code. Code is fine. Or else I am writing Java code. Just imagine. Later we can write Java code, but imagine I am writing these 3. Anyone. Submitted. Once submit completed, immediately job tracker respond, doing all these operations. After that, job tracker sending to task tracker submit the jobs into so-and-so date nodes. So just imagine friends, task tracker submit the job into this data node. Here one data node is there. In this data node, deer, beer, river, car, river, deer, cow, beer. This is the data available. 3 blocks. Task tracker submit the job into this data node. Okay. What happened immediately? Once task tracker submit the job, immediately coding execution started. What coding? Map reduce work started. That means same thing. The first phase of the mapping is a mapping process. Is read the data from the data node and according to logic. What is our logic? I want to find each and every word how many times repeating. This is my requirement. Okay, so according to the requirement, we are dividing each and every word. So mapper take the responsibility dividing the data. Remember, in peak time we are writing this code. How to we are writing? As a developer, we are writing first to divide it, then count it. Internally, framework also taking the responsibility. Mapper taking some responsibility. Reducers are taking some responsibility. So here the mapper responsibility is read the data from the data node, applying mapping logic. What is mapping logic? Divide each and every word into individual words. Once the mapping logic completed, it gives the output. That output we call the intermediate output. That intermediate going to the reducer input. The reducer responsibility is taking the input from the mapper, reduce the data, the final summation is giving the output. Final summation is giving the output. That is the final output. Reducer output. Once a mapping and reducer, those both the process completed, we get the output. That output we call the map reducing output. Okay. So here mainly, yeah, let's see this one. In this process, input taken from the master node, dividing into smaller tasks. The master output, the mapper output, go to the reducer input. In the reducer again, this reducer take the input from the mapper, doing the reducer responsibilities. Reducer responsibility completed, we get the output. Okay, that we know. Let's see some more internals regarding the same concept. Why map reducing process big data in less time? How it is possible? I have some big data is there. Those data I want to process in less time. How it is possible? Just imagine 10 terabytes. 5 data nodes, 1 data node, 2 terabytes, another 2 terabytes. Those 2 terabytes also we are processing less time because of the parallel processing. Because see here, our logic is there, our data, complete my data is there, dear be river, car river, dear car river. This is the data available in my data node. 3 blocks is available. Just imagine 3 blocks is there. 3 blocks we are storing our data. We means name of storing data. Processing time also 3 maps running parallelly. 3 maps running parallelly. So here, how many workers take the responsibility? For example, I want to build a wall. I want to build a wall. One person take 10 days time, but 5 people working parallelly to complete that wall. Within 2 days, we complete the work. Same logic is there. Internally, each and every block mapper is running. A mapper responsibility is read the data from the data node. How it is reading? By default, the splitting concept is there. Splitting is one of the concept. It helps to read the data from blocks to our logic. Okay. Once job tracker and task tracker submit the jobs, immediately mapper work started. What is the first work of the mapper? Is read the data from the data node. How to read? Yes, here one of the concept is there, splitting. What is splitting? It's logically read the data from the data node. There is no physical, splitting is only logical. It's coordinating our mapping logic and our data. By default, equal number of blocks. For example, our block is 64 MB. Equal number of blocks, equal number of splits coming. Equal number of splits, equal number of maps are running. For example, I want to improve my performance. For example, I have one code is there, one 1 GB data is there. I'm storing into 128 blocks or 64, 128 blocks, 8 blocks is there. I submit the query. Again, job tracker, task tracker, responsible is completed, and mapper started. It's keep on running. It's almost taking like, for example, more than 2 hours to complete that query. Very much complicated logic. Imagine, very much complicated logic. It's taking more time to process the data. But I want to cut down the time. I want to give the better performance. So I want to improve the performance. How to improve the performance? Improve the number of mappers in real time also. How to improve the number of mappers? Simply cut down the split size. By default it is coming. Equal number of block size, equal number of input splits is coming. Equal input splits, equal number of mappers are running. But I want to put the mappers because my logic is complicated logic. I want to improve the performance. How can I? Yes, For example, my block size is 128 MB. I decided my split size is 64 MB. By default, block size split size is equal, but I want to control it also. Decrease the split size. Once mapper work completed, then mapper give the output. That output we call the intermediate data. Mapper give the output, no? That is a see this code also. Here, beer river is there, car river is there, their car, beer is there. Thing happen, mapper, dear ones, beer ones, every ones like this, dividing each and every word individually. Then car river, dividing each and every word individually. Then dear car beer, dividing each and every word individually. Okay. After that, the mapper gives the output. That output we call the intermediate data. That intermediate data now go to the reducer. Reducer will read the logic, applying reducing concept. Once reducing concept completed, we get the output, final output. We get the final output. So that two stages is there: mapping stage, reducing stage.